Hello everyone, welcome to Excel Maths. Today we are going to be discussing this question number 5 from June 23, paper 3, mechanics shadow series. So let's get started. We have given the question. Let's go through the question quickly. So this is what the question is and is of 11 marks. So we have a small ball which is projected with the speed of 42 meters per second. So let's find out the horizontal component. So ux is going to be 42 cos alpha and uy will be 42 sin alpha, right? And what else is given? We have given this horizontal distance, which is 20 meters, and the vertical distance 10 meters. So okay, fine, let's continue. So we have the informations given. Ux is 42 cos alpha, Sx is 20 meters. If you read the question, after moving for t seconds, so t is capital T, the ball passes through a point A. This is a point A, it passes through. So the moment it passes through point A, it travels horizontal distance of 20 meters and this point A is 10 meters above the horizontal plane. It moves freely under the gravity, that means acceleration is 0. So we have to show a part which is of 2 marks. So we can say Sx equals ux, give me a sec, ux t plus half at square, that would be 0. So I'm just writing Sx equals uxt as acceleration is 0 for horizontal motion. So Sx is 20. Sx is what? Horizontal motion. Like all the things we're discussing about, they are with respect to horizontal movement, which is equal to 42 cos alpha times t. So t is going to be 20 over 42 cos alpha. So if we simplify it, we're going to be getting 10 over 21 cos alpha. So this is what we were supposed to prove. So we've got our 2 marks. Now for second one, we have to show tan square alpha minus 18 tan alpha plus 10 equals 0. This is minus over here. Okay, so for B part, I think we are going to be, that was A part and this is B part. Let's take vertical components. So uy is 42 sin alpha. Sy, the horizontal distance is 10 meters. What else do we know? Acceleration will be g only. Okay, and time is t. So can we say Sy, vertical distance traveled, Sy is going to be equal to uyt minus, because upward motion is opposite to the gravity, half gt squared. Let's substitute all the values. So 10 is equal to 42 sin alpha. We have the value of t, so going to be substituting it. 10 over 21 cos alpha minus half, 9.8, 10 over 21 cos alpha squared. So we just have to simplify this. It can be written as 20 tan alpha sin alpha over cos alpha and minus, if we simplify this, we're going to be getting 10 over 9. It is 1 over cos squared alpha can be written as sec squared alpha, right? So we're going to be writing sec square alpha there. Okay, if we multiply by 9, we're going to be getting 90. That is equal to 180 tan alpha minus 10 sec square alpha. Okay, let's divide by 10. That is going to be 9 is equal to 18 tan alpha minus sec square alpha. Okay, can we write sec square alpha as 1 plus tan squared alpha. Okay, so we're going to be substituting it there. So 9 is going to be equal to 18 tan alpha minus 1 minus tan squared alpha. I hope it makes sense. Now let's move it around, make it positive. Tan squared alpha minus 18 tan alpha plus 10 equals 0. And I think this is what it was asking us to prove for. Tan squared alpha minus 18 tan alpha plus 10 equals 0. Let's find out the value of tan alpha. So if you solve it, you are going to be getting the value of tan alpha to be, we're going to be getting two values, 17.42 and 0.57. So because yeah, these two values we're going to be getting, right? Okay, now let's go for, well, for B part we were actually needing to prove this only. This is something, I mean, the values are actually going to be needed to solve the C part. So let's, what the C part is, find the greatest possible height. The greatest possible height in meters of the ball above the ground as the ball moves from O2. Okay, tell me one thing. If I just reduce the angle, the ball won't go higher up. I mean, it won't go very high. If I increase the angle, so the possibility of going up would be, obviously, it would be more likely to go reach higher heights, greatest height. So this is what we have to find out. We have to find out the greatest possible height. So for greatest possible height, obviously projection would be with some angle. So over here, we are going to be taking the larger angle out of these two. So this value is going to be working for us. So can we quickly find out alpha from here? So tan inverse 17.42, what that gives us, is it 86.71 degrees? So yeah, we're going to be keeping it. Now let's do C part. So for C part, we have to find out the greatest possible height. For the greatest possible height, you would be understanding that velocity, final velocity will be 0. So when final velocity is 0, we're going to be achieving greatest height. What equation can we use? V squared is equal to U squared minus 2GH. I hope you know why it is minus there. So because it is 0, so we can say U squared is going to be equal to 2GH, or making H the subject, it is going to be U squared over 2G. Again, this U is basically Y factor, vertical velocity everywhere. Okay, so let's substitute the value. So it was, vertical was 42 sine alpha. So 42 sine alpha over 2 times 9.8, and we have to square this value. So let's quickly find it out. It gives us 89.68 meters. So this is the maximum height it reaches. For the last part, let's see what the last part is. Most of the time it is like limitation, and yes, it is. So limitation could be because it's a ball. So we have not we are not keeping the spinning of the ball. Generally when this ball comes, so for limitation we can say the ball is going to be spinning as well. So it will, air resistance we have not to include, so except air resistance, it could be the spinning of the ball. Spinning of the ball. Yeah, perfect. Thank you so much.